Professor Hashimoto with us, who will deliver a talk on humanoid robot research and its applications. So, a brief biography about Professor Hashimoto is he has received his Bachelor of Engineering and Master of Engineering degrees in Mechanical Engineering in 2004 and 6, and a PhD in Integrative Bioscience and Biomedical Engineering in 2009, all from Waseda University, Japan. He held research positions in France and Japan, including at Collège de France, CNRS, and Meiji University, before joining Waseda University's Graduate School of Information, Production, and Systems as a professor. In September 2024, he was also appointed as Associate Dean of the Graduate School at Waseda University, Graduate School of IPS. And his research focused on legged and humanoid robots, earning him prestigious awards such as the IEEE RAS Japan Chapter Young Award. And it would be really interesting to see his website for the work he has been doing. So I would hand over the dais to Professor Hashimoto.
Thank you for the let me set the presentations. So title, today's title of my talk is humanoid robot research and its applications. So first, briefly, let me introduce you about the Waseda University. So Waseda University was established in 1882 by Shigenobu Okuma. And Shigenobu Okuma was also the Prime Minister of Japan. And after the establishment of the Waseda University, first the school started with its 80 students. And after that, the Faculty of the Science and the Engineering was established in 1908. And in 1982, we celebrated the 100th anniversary. And in 2003, our graduate school of information production and systems was established in Kitakyushu in Fukuoka. Not in Tokyo, but we are in Fukuoka. And this graduate has three fields: the information architecture field, and the production system field, and the integrated system field. We say this is IPS. And in 2022, we celebrated the 140th anniversary. And the Waseda University has in total around 50,000 students. And among them, around 7,000 students are the international students. So there are many international students in Waseda University. And the IPS is located in Fukuoka. So here is Tokyo, but we are located in Fukuoka. And in Fukuoka, there are many international students, and we are recruiting the students not only from Japan, but also many countries. And as I told you, our graduate school, the name of our school is Graduate School of Information, Production and Systems. And we have three fields, and I belong to production systems field. And the Professor Matsumaru, and he will have a talk the day after tomorrow, belongs to the information architecture field. And each field has around 9-10 faculty members. And inside of the production system field, there are 9 professors. now. And I'm here, and there are several professors who are researching about robotics. So this is a brief introduction about our graduate school. And I research on the humanoid robots, and the history of the humanoid robots in the Waseda University has a long history. So in 1967, we studied the research about the Waseda legged robots. And we continue to research about the legged robots, and we have developed the fittest prototype. The name is Waseda leg number 5. And here is the videos, and here is the old videos of the Waseda leg number 5. So this video was taken in 1971, so around 50 years ago. So at the time, so this video itself is very old, and here is a kind of the computers. But the specifications of the computer is worse than the smartphone now. So, but at the time, also around 55 years ago, the robot realized the two-leg walking. But at the time, it took around 40-50 seconds to make one step. So it looks like fall down, but the main materials are made of iron. So the robot itself is very heavy. So, but here's a weight. But the robot tried to maintain the center of mass, a center of gravity inside of the support of polygon, a center of pressure inside of the support of polygons. So this was leg number 5. And we continue to research about the humanoid robot, and Professor Ichiro Kato, he managed the robotic teams, and he developed the robot one. This is the first humanoid robot, human-sized humanoid robot in the world. And also here's videos of the robot one. And the lower limb is the same with the leg number 5. But now the robot have 2 arms, and there are two cameras. This looks like a body, but there are 2 cameras. And by using the arms, a robot could write several characters and so on. So this is the upper bodies of the robot one, and also here is videos of the lower bodies. This is the same with Waseda leg number 5. And after that, we continue to improve the bipedal walking technologies. And we developed Waseda leg number 10 and number 12 and so on. And here's the videos of the Waseda leg number 12. And this video was taken around 1990s. And so this video was taken in 1991. And at the time, the robot walking speed was much improved. So once it took less than 1 second to make one step. But this video is was very old videos. Okay. So this was the leg number 12, and then we want to develop the humanoid robot, Waseda Bipedal humanoid robot. And this kind of robot was mainly developed by my supervisor, the Professor Takanishi. And under his supervisions, I graduated from his laboratory. And this is my bachelor and master and the PhD thesis research. We have developed the bipedal chair, and this me, and this photo itself was taken more than 20 years ago. And at the time, the robot realized climbing up and down stairs, carrying humans. And after getting my PhD, I joined the humanoid group, and I do the research about the humanoid robot. And also I continue to research about the electric robots, which for the disaster response, and also this quadrupedal wheeled robots. So later I will explain about the details of these robots. And the reason why we researched on the humanoid robots is to understand humans. So we mimic the mechanisms of the humans, like joint dimensions, and also human has a waist. And the human can move the waist, then the waist part will be important to realize the human like walking. And the human has a foot arch structures. And the foot arch structure, some scientists say that the foot arch structure can contribute to the bipedal walking. But by using the robot, we can evaluate quantitatively how the human foot arch structure contribute to the bipedal walking, because the humanoid robots has many sensors. And this is the knee straight walking. So during the walking, the waist, the pelvis moves like humans. And by utilizing this kind of joints, the robot realized the knee straight walking. So after getting my PhD, I worked on the motion generation of this kind of robots and the mechanical part. And based on this kind of technologies, there are many applications. And so first, we collaborated with a sports scientist. So this is the motion capture data obtained by our cells. And the Waseda University is also famous for famous in the field of the sports science. And we have collaborations with professors in the sports science, and most sports scientists measure the humans from the side. But also when we research on the bipedal humanoid robots, we realize that the waist motion is also important. So we proposed the professors in the field of the sports science to obtain the data from the front of the humans. And surprisingly, we noticed that also during the running motions, the human utilizes the pelvis, the waist motions. So not only leg motions, by using the waist motion can contribute for the kicking motions and so on. So after this data, after obtaining this kind of data, we surprised that several TV shows say that Usain Bolt also he is a Olympic champion, and he utilized the pelvic motions, the waist motions during the running. So we are surprised. But based on this kind of analysis, we developed the simple legged robot, which has a waist, and also human has a kind of the mechanical springs in the legs, inside of the muscles and the tendons. So this is a simple mechanisms. Here is just a compression springs, and here is a waist. So just using the waist motions, the dog could jump. So based on this, we developed the leg parts like this, and but the control parts was not so good, but the dog could jump little. And we developed the lumbar joint to standardize the running motions. So this is the one application of the humanoid robot, and the next one is a kind of the collaboration with the psychology persons. So this is a emotion expression robot. So far we have developed a full body emotion expression robot to make a correlations between the robot and the humans. And what is important with the robot need to tell the emotions to the humans. The emotion expression will be the interactions. So this head is very complicated, and inside of this head, there are 24 motors, 24 actuators. And we developed a human-sized humanoid robot. But of course, if you consider about the interactions between the humans, it's impossible to carry the emotions completely. So that's why we try to implement the exaggerated expressions like this. But this is not so perfect. So next we consider to implement the comic symbols like this. So also Japan is famous for the manga, the comics. So in the comics, in the manga, there are many symbols to express emotions. So we try to implement this kind of marks on the robotic head, and we did the questionnaires if you prefer this or not. So here's the nationalities. So Western countries people tend to prefer without comic symbols. Also, there are several people who tend to prefer comic symbols. But surprisingly, the Japanese people read manga a lot maybe than Western peoples. So Japanese people tend to prefer comic symbols. And also Asian people, excluding Japanese, also tend to prefer with comic symbols. And I surprised that several Western people don't know this kind of mark. So this is a mark for the anger, but I surprised that several people don't know this kind of marks. I'm not sure about the Indian peoples, but for Japanese it's common to use this kind of mark. Okay, so this is the application with the correlations with the psychology. And the next is a disaster response. So in 2011, there were big earthquakes. Also at the time I was in Tokyo, so I surprised the building was shaking heavily. And unfortunately, the nuclear plant was damaged. And it was very dangerous for humans to enter such kind of nuclear power plant. But what is important is the damage situation survey and recovery work. And in the future, it is very nice if there will be the robot which can work on behalf of the humans. So there was around in 2018, there was a national project. The project name was Impact, and this project was conducted by Cabinet Office of Japan, and we tried to develop the legged robots which can work on the disaster site. And also in this project, there are many researchers, and these several researchers are working on the flying robots, and the several researchers work on the snake type robot and so on. But we were in charge of the development of the legged robots. And in this project, we designed the legged robots. Not only the bipedal walking, but also this robot can do the crawling motions on the rough trains, the double piles. Because for the bipedal robots, it is easy to falling down on the double piles. So that's why we chose the crawling motions on the rough trains. And if there is a vertical ladders, also the most challenging point was climbing up the vertical ladder. So vertical ladder was very challenging environment for the robot to climb up. But this kind of the I'm sorry, my PC crashed. But in this project, we have developed not human robot, but for living robot. there are many videos. So, my laptop does not have a GPU. Let me restart the PowerPoint. So when I was a student, there were no GPU, so the robot just use a CPU. Nowadays, it's important to use a GPU for the environmental recognition for the robots. And this is the same slide, I think. So the robot climb up also the vertical ladder and also climb up the stairs, something like this. So especially so far we were working on the hardware side and the motion generation part of the electric robots. And this is the electrical system of this robot. The name of this robot is the Warek, the Waseda Rescuer. So it's the Warek. And there is one CPU. And so in these videos, the robot does not have environmental recognition sensors like a camera, and lidars, and so on. So that's why in this video, robot already know the environment. So known environment at this stage. So later I will tell you briefly about the integration of the vision sensors into this robot. But at this stage, the robot just has one CPU and to measure the acceleration and the angular velocity and the angles of the robot bodies. There is one IMU, inertial measurement unit, and there for the communication protocols. At the time, we use the Ethercat. The CAN is famous for the communication protocol, but the CAN is the communication speed is a bit slow, so we chose the Ethercat. And there's a USB module to use the post-probe sensors. And in this project, we are in charge of the development of the electric robots. And this is the improved version of the robot. And we implemented the lidars to measure the environment. And there are two stereo cameras which help the remote control of the robots. And this is the inside of the robot bodies. And in this case, in this improvement, we implemented the batteries. And also there are several, this orange one, there are four lidars and two cameras, something like this. And for the environmental recognitions, we collaborated with many researchers. So in this project, for the electric robots, there are around 12 teams. And several teams, including the high-tech, it was the Tokyo Institute of Technology, but last September they changed the name of the university to the Science Tokyo. So the professors from high-tech and AIST is a national institute, and they are working on the simulations of the robot, and their hardware part is about the hydraulic actuators and the robotic hands and so on. But this robot used the electric actuators. So hydraulic actuators was developed for the next versions, but the next version was not developed. But also several researchers were interested in the hydraulic actuators, but this robot used the electric actuators. And what will be important is the environmental recognition part. So audition is like a human's ears, and in the disaster site, the sound source localizations are sometimes important to detect, to find the persons. And also image processing part, including the SLAM, simultaneous localization and the mapping. And this kind of environmental recognition part is important. And before this project starts, I do not know about the details of this kind of technologies, but through this project, I could obtain the knowledge about the environmental recognition and also the remote controls. And so in this project, of course, the ultimate goal will be the development of the fully autonomous robots. But it takes long time. So sometimes remote control will be important to help the robots by humans. So this is the remote control by using the kind of the goggles. And there are two cameras. So based on human hands, we can control the robot arms. And also this is important technologies. This is the remote control from the virtual bird's eye view. So when remote control the robots, what the limitation is we can just implement it in the robots, on the robots. So, but sometimes the bird's eye view will be important for the remote control. But if there is no cameras outside of the robots, we cannot obtain the bird's eye view. So several researchers do the research using the flying robots. Flying robots obtain the view, and such kind of view will be transferred to the humans for the teleoperations. But for such a purpose, we need one more robot. So in this, again, I'm so sorry, I'm very sorry about that. Maybe I need to restart again the PowerPoint, but for this kind of virtual bird's eye view, we used the images which were taken by the robot itself, but several seconds before. So this is very interesting technologies. But this technology was developed not us, but one professor in Kyoto University. He retired. Now he moved to the university, to the Osaka Institute of Technology. Professor Matsumaru. So the robot moves. So robot continue to take the pictures, and we use a fast image. And if the robot can do the SLAM in the robot can do the simultaneous localizations, robot knows the correct positions. So we can superimpose the CGs of the robot to the fast image. So that's why this is a virtual bird's eye view. So, and also there were several user interface and tangible user interface. So this kind of integration. Also yesterday we have a project meetings, but we have obtained a lot of experiences about system integrations. And in this project, as I mentioned, that other researchers are working on the environmental part and also the remote control part. So there are many operators in the researchers in different universities. So PC1 and the students from the Kyoto University working on the bird's eye view image, and also researchers from the AIST worked on the sound perceptions and so on. So there was just one law, but behind the scene there are many researchers and these students, something like this. There is just one law, but outside of the law there are many operators, and also there are many applications. So this is not realistic. So during this project, this picture was taken in 2017, and 1 year later we continue to integrate the systems, and the appearance of the robot is the same. But this kind of PCs were implemented inside of the robot. So this is a kind of the system integrations. So of course, there is PCs outside of the robot for the teleoperations. But for the environmental recognitions and also the environmental recognition and so on, we use the PCs inside of the robots. So there, I wrote the sensor PC, but this is a kind of the GPU for the web camera. cameras and the laser edge printers. And also we use a CPU for the motion generation for the robot. So to develop just one robot, there are many researchers. So during this project, I was very busy just for set up the meetings. So you can imagine how difficult to manage the meetings. At that time, this before the COVID-19. So at that time, online meeting was not so familiar. So now we can easily set up the online meeting, but this is just before the COVID-19. Yeah. So this is the one applications, and the last application is a theater. So a kind of a theater robotics. So we collaborate with one companies, and do you know the manga artist Osamu Tezuka? Osamu Tezuka is most famous, the most I think famous comics is Astro Boy. Tetsuman Atomy in Japanese. Astro Boy. And it also in his comics, there is a comics named Blackjack. Blackjack is a kind of the illegal doctor, doctor. And in this comics, there is a scene something like this that the name of this person is not person. The name of this character is Pinocchio. And this is a manga scene of Pinocchio, a bar scene of Pinocchio. And Pinocchio, actually, she has a twin sister, and the twin sister is a human, but the twin sister has a tumor. And inside of the tumor, there are brains and the limbs and the organs and so on. And everything was separately contained within the tumor. And in the manga scene, and the Dr. Blackjack extract the organs and the limbs from the tumor and assemble the organs and the limbs. And he not developed, but he regenerated. So this human theater want to do the act in the real theater. So robotics technology can contribute to this kind of realistic the real act. So this is the artificial heart. So this mechanism is very simple. We just use a one cam mechanism. But if we put the exterior, something like this, it looks like a real heart. And also we developed the Pinocchio legs and the Pinocchio arms and the Pinocchio hands and the Pinocchio hands and the Pinocchio heads and so on. And here's a Pinocchio, and during the theater, in the theaters, the actors integrated, combined, assembled each part, and during the theaters, in the theaters, the actor developed the Pinocchio. And this picture looks like very cute, but we take the pictures from the bottom side. It looks like very cool. So this is what I did until 2017. So since 2018, I've been independently running my own laboratory since 2018. And after that, I continue to work on the robots, and I think we can summarize like a word of the adaptive robotics. So one is environmental adaptive robotics, which means the robot can adapt to the environment. And also intuitive adaptive robotics means the robot can adapt to the humans. Adapt to humans means the robot can realize that intuitively understand human intentions and also perform the appropriate actions. These are kind of the human-robot interactions. So regarding the environmental recognition, to adapt to the environment, of course, we need a lot of knowledge, But thanks to the previous project, previous disaster response project shown in this slide, I could obtain a lot of knowledges. So now I'm working on the environmental recognitions. So far, I just work on the motion generation part for the electric robots, but now I'm working on the environmental recognition part also. So first, this is the environmental recognitions. So many researchers are working on the environmental recognitions of the shape of the environment. But what will be one more important thing may be we will be the environmental property estimations like slipperiness and softness and so on. Also, if we look at the chairs, we can imagine that this is not hard but soft. So this kind of imaginations will be, this kind of estimations also helpful for the robots. So we use a kind of deep learning method to estimate this kind of environmental properties. And also one student in my laboratory worked on the paddle detections. So paddle detection is not so important for the cars, but the ice, but here is too hot, so it's a bit difficult to find the snows and so on. But for the mobile robots, sometimes we need to detect paddle and also icy environment, which is very slippery. So some students, I think some audience know about the YODO, which is object detection AI model. And based on this, we improve this, and this is the real-time recognitions of the paddle. And also this time, one more environmental recognition research. So in the disaster site, there is a smoke, and also sometimes there is a fog and so on. So if we just use the normal RGB cameras, it's impossible to see behind the smokes and so on. But when we use infrared cameras, by using the infrared cameras, we can find the humans, something like this. There are two humans, and in this scene there is one human. But the quality was not so, of course the quality of the infrared cameras was not so good compared with the RGB cameras. So now we are working on to develop the more high quality images by integrating the RGB cameras and the infrared cameras by fusing the two images, not only two images, but we try to develop the high quality images, something like this. So this is just a research, computer vision research as well. But I know about this. But I'm working on these kind of topics. And if we can recognize the environment, what will be important is the motion planning and the motion generations. The challenging point is the motion generations of the electric robots still are challenging. So, but nowadays, by using a kind of the machine learning, there are many good humanoid robots and electric robots. So we also continue to work by integrating the, I'm not sure you know about the model predict control, but we try to integrate the model-based control and the machine learning method to generate the electric robot motions. And of course, I'm interested in the deep learning. So this result is not this result itself is very predictive, but I'm continue to search for the best combinations for the model-based control and this kind of reinforcement learning. And this is the research about the electric robots, but there's the anatomy. There will be the common parts between the electric robots research and also the manipulation research. So also I studied about the manipulation research, and of course for the manipulations, the object detection like environmental recognition will be important. And also for the manipulations, in these videos, the robot just use a simple grippers, but the estimation of the center of mass is also important sometimes. But if if the center of mass is not centered, it can rotate and it's easy to fall down. But we can estimate the center of mass, which will be helpful for the movements. So I started to work on the manipulation research. But also to realize that in real world, the real heart, we need a real heart robots. So nowadays, there are good commercial for electric robots, but still there are several limitations. So we try to invent the new mechanisms. So this is the one leg robots, but based on this, we have developed a quadrupedal robots and the two-leg robots. So this is the motion generation part. And for the remote controls, also I'm not familiar with the AI, so I continue to research. I continue to study about AI like a student. So this is a fundamental research using the large language models. LLMs.
Please put the tape in the box and hand it over to me.
So in this video, the input is a voice, the speech. And based on this speech recognitions, now robot that don't move, robot consider how to move using the GPT. And on the tables, there is a tapes, and now he told the robot that to bring the tape. But this is just not flying robot. If the robot is a flying robot, the robot can fly, but there are several wheel robots. So the input is just one sentence, but the robot, this is the control of the multiple robots. The operations for the multiple robots. So this is very primitive.
Please put the tape in the box and hand it over to me.
Research, but we are working on this kind of topics using the electric robots and also mobile manipulators. So this is a fully remote control by using the hand gestures, fully remote control of the mobile manipulators. So this is a wheel robot with arms, but so teleoperating just by using the hand gestures. Also, this is not perfect, but we continue to try to find what are the better ways for the remote control of the mobile robots with arms. So this is the mobile robots, this is the wheel robot with arms, but now we have the leg robots with arms. So now we are trying to integrate such kind of leg robots with arms. Okay, so my specialty is about the robotics, but like us students, I continue to improve my skills about the AI. So by using the robotics and the integration of the robotics and the AI will be important. And also by using our knowledge, what is important is to provide a solution for for solving social issues. So of course, China and the US and there are many companies who are developing the humanoid robots now. Unfortunately, there are just a few companies in Japan. They are developing the humanoid robots now. But I research on the humanoid robots, but also I have several doubts if the humanoid robot will be useful or not in the human society. So concerning the short-term range, I think other technologies other than humanoid robots will be helpful. So we have a collaboration with several companies, and we try to improve the operational efficiency in the lodging industries. So in Japan, there are many tourists, but the number of laborers are becoming decreasing. So we have a collaboration. The lodging industry company told us several problems, and one is waste measurement in the garbage pits. So we just use the sensors and the controllers. There are no actuators, no motors, but by using our technologies about the sensors and the sensor data analysis, we can estimate, we can measure waste quantity, waste volumes. And also in Japan, there is a big public bath in the hotels and so on. And in the cleaning of the public bath is also the heavy work. So indoors, there are cleaning robots like Roomba and so on. But there are still no robots which can clean the public bath. Public bath is very large. So every day they must clean up the bath. So we have developed this is just a prototype, but also we continue to improve this kind of robots. So this is the robot, anyway. So based on the technologies of the humanoid robots, in my laboratory, we are developing the technologies to improve the operational efficiency, something like this. Okay, so my time is 45 minutes, and this is the last slide. So this is the summary slide. So in this talk, I briefly introduce you about the Waseda University. So we belong to the Graduate School of Information Production and Systems, and please speak about the Waseda University has a long history in the humanoid robot research. And also I did the research about the humanoid robot, and there are many applications. We have a collaboration. The collaboration will be important, I think, in the field of the robotics. So I collaborated with a sports scientist and a psychologist, and we developed the disaster response robot, and also here the robot. And through these kind of collaborations, I cultivated technologies like environmental recognition and motion planning and generations, and also hardware design and development. And the robot, there are three key components of the robot: sensor, actuators, and the controllers. So if the machine has this kind of three key components, which becomes a robot. So nowadays, controller includes the AI, artificial intelligence. So what this is my opinion, but applying the humanoid robot research to benefit society is important. So using actuators, if we start to use the actuators, the system becomes more complicated. So just using the sensors and the controllers, we can provide several solutions to benefit society. So that's why to solve the labor shortage in the industries such as the forging industries, for the waste level measurement, first we just use the sensors and the controllers. And the next step will be if we can develop the garbage collecting robot on behalf of the humans. Dog can go to the garbage bins to collect the garbages and the waste. And we have a cleaning robot. Cleaning robot includes the sensors and the actuators and the controllers. So this is kind of the robots. Okay, so this is my talk, and thank you for your time. Any questions? Anyways, but I forgot to mention one thing, but I have several souvenirs. I think that I'm not sure the number is enough or not, but I think less than 30, so I think that. So the Okuma, do you remember that the Okuma Shigenobu established the Waseda University, and he was the prime minister. And the Okuma in Japanese, Oki, O in the big, and the Kuma in the bear. So Big Bear. Big Bear is a character of the Waseda University. So Waseda University have, I'm sure you like key holders, not going down. So also the sensors, the price of sensors is also important. So when I was a student, the IMU sensors was very expensive. At that time it was very expensive, but nowadays in the smartphones there is IMU sensors. So that's why the price surprisingly decreased. I think the most important thing is the robust hardware. And next will be because the robot is very expensive. So when I was a student, if the robot fell down, robot broke down. So this video was taken without the lift, but behind, outside the videos, we prepared to catch the robot if the robot falls down. So, but at the time, if the robot once falls down, robot broke. But nowadays, also the weight, the mass is also important. The mass was very heavy, not so heavy, but 60 kilograms. But nowadays, the Chinese humanoid robot is very like 30 kilograms, 35 kilograms, because one reason is that the height is smaller, like a kid, like a child. So the size becomes small. If the size becomes small, we can use small actuators like which is used for the drone, the flying robots. So that's why humanoid robot, the robustness was increasing, I think. And also the pricing is also important. And also there is a gap between the simulations and the real environment. So what the best way is, of course, we use a robot for the learning. So, but for such a purpose, we need a robust hardware. But as I told you from the reliability of the robot became good. So that's why, and also the gap between the simulations and the real robot becoming smaller and smaller. And there is a good hardware. So that's why there are several research. There are many researchers who are using the machine learning for the robots research. Design.
Professor Hashimoto, I have a question. I just found from your biography that you have done your bachelor's, master's, and PhD in mechanical engineering. So, as a mechanical engineer, what do you think would be the direction in which the education and research and mechanical engineering should move at this point?
Yeah.
Because you work on many areas like AI and something related to computer vision and augmented reality, etc. So that means the scope of your work is like stretching really big.
Now it becomes working wider and wider area. But first, for the student, what will be important is to measure who will be the professional in the one field. So in case of me, it was mechanical engineering, and so this is my supervisor, Professor Takafumi. His policy was something like this. We belong to the mechanical engineering, but for the bachelor thesis, we developed the real hardware, and for the master thesis, we will develop the motion control part. So through this kind of bachelor and master thesis, we can obtain both about the mechanical engineering part and also the control systems. And after getting PhD, I continue to improve both. And but now, after getting my PhD, I started to research. Also, I continue to research about the AI. So I'm the beginner. I think about the AI. But first, for the student, it's impossible to run everything. So when I was a student, my specialty was mechanical engineering. But there are many chances to have a presentation at international conferences. So when I was a student, when I go to the conference, I just attend my sessions and the sessions which is strongly related with my research. But nowadays, it's very fun for me to attend the other sessions to increase my knowledge. So what's really important for the students is first, of course, they must be the professional for the one field, but if they will be the chance to increase the knowledge, something like my talk or other professors' talk, it's very important for you to attend such kind of talks. Then, of course, first, I didn't know, when I was a student, it might be pity to say, but when I was a student, I didn't know about the word about SRAM. SRAM is the simultaneous localization and the mapping, but when I was a student, I didn't know. But when I attended the international conferences, there is a sessions whose session name is SRAM. So there are many SRAM sessions. So, but I didn't know what is SRAM. So also there is a humanoid robotics sessions. So I attend just a humanoid robotic research sessions. So if you attend different sessions, there will be the chance to increase the knowledge. Okay.
Just adding into what Dr. Shoyusan asked regarding the challenges. So, first of all, thank you so much for sharing your work, and especially the comic part was very interesting because that was an area where I could relate to and the theatre too. But I wanted to ask, what ethical challenges do you face here? Seeing that we see human HCI as a very important emerging field, what happens to the idea of the human? What ethical challenges do you think it envisions?
Article challenging
Ethics.
Ethics.
Yeah. This is from a social sciences and humanities intervention here.
Yes. Also, when I was a student, there was a sessions about the ethics. So sometimes I have I have a collaborations with researchers who research on the ethics, and it was difficult to say from which part I should start to talk. But when I attended the conference in Italy in European countries, there are many Christians. So when I attended the sessions about the human sessions, there are several people suddenly came to the rooms and they say, alien go home, but they say something like this. But several people say that the Christian people don't like to develop a human robot, but I think this is not true. They like the human robot, but the ethical part is, of course, important. Also for the artificial intelligence, now to improve the quality of the artificial intelligence, one way is to increase the data set. So for the data set, there are many privacy information and so on. So yeah, there will be discussions. But regarding the ethics, yeah, we must be careful. So what's important is that such kind of collaboration is really important, and also the establishing law, what are law, when establishing a law, that is also important. So there is a funny story that there are one company who did the experiments of the robot on the public road. But when the Japanese law was established, there was no roads, just cars. So, but the police arrested the company persons because it was very dangerous and also there are many humans. So, but when the police checked the roads, the robot was not defined. So the company person was not arrested. But such kind of communications among beyond the robotics community collaborations and the discussions, continuous discussions is also important. So there is sessions about robotics and ethics.
was this particular, where was this applied, the application for this whole body motion?
Yeah, at that time, of course, to increase the interactions between the human and the robots. But nowadays, of course, when we made a presentation of the conference, of course, every time we ask the question, why don't you use a display? So if there's a display, we don't need to develop this kind of complicated heads. But if robot has a display and if human look at from the side, human cannot recognize the face. So that's why. So every time we answer something like this, but the application is so. First is to understand human recognition is also was an interesting topics. And also this time I skipped these videos, but
続きまして、びっくりした瞬間のマスオさん。
So I think you cannot understand the Japanese, but this is a robot-induced laughter stimulations, and also so not this is not a one application, but this is not all, but the one application is something like this. So human interact with the robots, and what really important is for the physical health we can work, but for the mental health, laughter is important. So there is so far we have developed several sensors to measure the real laughter. So sometimes we just laugh, but there is sometimes a fake laugh, smiling. But so to detect the real laughter, it's important to measure the muscle activities of the bodies. So if we can recognize the real laughter, and the robot can recognize the conditions of the humans, robot change the motions and try to move. But I'm not sure we really need to use a real robot. Just use a screen video game. But we did a real test, but just using the videos for real robot. But there in the applications, I hope.
How do you know whether the laughter is it fake or for the robot?
Yeah. So just measure the
Right?
muscle activities. Just recognize the face. We cannot detect that this is real or fake. But just measuring the muscle activities, we can detect the real laughter.
I think there are no further questions. So, as a token of appreciation, so I would like to invite Professor Surul Shah, who is our head of mechanical engineering, to please hand over a token of appreciation to Professor.
So I have another This is a gift from the Waseda University. So thank you very much. Here are many souvenirs for everybody. So please take one. Otherwise, I must bring one.
I would like to thank everybody who has attended the session. We will also Special thanks to Professor and we will have another session on Thursday from 6 to 7. Professor Matsumaru will be talking about topic related to robotics. Thank you. Pleasure meeting you. Everything.